students, now we are going to see data structure model question paper 1 part C. 20th question, explain in all operations in traversal. So traversal means traveling in a graph. So what are the operations we can use? It means first of all insertion and second is deletion. So first we are going to see the insertion operation. It is an operation in which we can apply on all the data structure. Insertion means adding an element in a given data structure. This operation is successful when we can say it when the element is added to a required data structure. The insertion has same name as mentioned like in array, linked list, graph, trees, etc. As a stack is one end only, this operation, that is insertion operation or deletion operation, can be done in one end. The stack is nothing but a last in first out. So which we inserted last, that can be serviced as a first element. So according to this operation is, that is in addition, insertion operation can be done by the push operation in stack. So this is also called as NQ, that is entering into the queue. Insertion in stack is, the given example is given for you for insertion operation. Here according to the rules we can declare it and call it. Now here we use the operation push. So first push 4, so that is inserted first, then push 3, then 3, push 2, the value is inserted, push 1, then the value is inserted. Now the in push up, in stack operation, the topmost element is 1, the downward last element is 4. So here 1 is inserted at 1 is inserted lastly, so that can only can able to get the service first. So insertion is done in this procedure only because it has only one end. Likewise deletion also done like it. It is the operation which we apply on all the data structure. Deletion means deleting an element in a given data structure. Deletion has the same name as in the array, linked list, graph, etc. Here also this deletion is done by pop operation. This pop operation can also be called as DQ, that is deleting from the queue is shortly called as DQ. So according to this, the element is deleted. Which element is deleted? The first element can only able to delete it, which because it has only one end, the topmost element can only be deleted. So according to this, 1 is deleted and output we will receive it as 2, 3 and 4. Second, that is 22nd question, explain in circular type of queue. A queue is a linear list in which data can only be inserted at one end called the rear and deletion from the other end which is called as front. This is queue, this is a type of queue. So this is the opposite of your stack operation because it has two end. One is for insertion and one is for deletion. The insertion end is called as rear and the deletion part is called as front. So first this takes the operation first in first out. Like means if who stands in a queue first will get the services first. So here the restriction ensures that the data are processed through the queue in order in which they are received. So this condition is checked. In other words, a queue is also called as first in first out, as we already seen. Right. The example, the people waiting in a line at a bank cash counter form a queue. So based on this, queue operations are two type, that is NQ and DQ. NQ operation is used to insert the element at the rear position of the queue, and DQ is used to delete the element from the front position of the queue. Here it is given an example and algorithm for how we can able to insert an element in a queue using the rear operation and front operation, right? Only thing is to check whether the queue is empty or not. If it is overflow, we can't able to insert the queue. Likewise, deletion also, empty condition has to be checked. There has to be non-empty, that is if there is no element, we can't able to delete the value. So the value is checked. Then comes the 22nd question. Explain the types of graph. So there are various types of graph: directed graph, undirected graph, subgraphs, etc. So first we are going to see the directed graph. A directed graph is a graph that is a set of objects called vertices or my node that are connected together, where all the edges are different direction from one vertices to another. One can formally define a directed graph as like G is equal to, G stands for graph, N stands for node, and E stands for edges. Consists of set of nodes which is called as N, and a set of edges are called as E, which are ordered pair of my element N node. Right? Undirected graph. An undirected graph is a graph. Here a set of object with nothing but vertices, or else called as node, that are connected together, where all the edges are bidirectional, that is up and down, both the direction. A node can travel in both the directions. A direction graph is sometimes called as undirected network. It contrasts a graph where the edges point in a direction is called as directed graph. Third one, subgraph. A subgraph S of a graph G is a graph whose set of vertices and a set of edges are all subsets of G. The second graph is a subgraph of first figure, but it is neither edge by induced nor vertex induced. Nothing but a subgraph is nothing but a portion which can be separated from my main graph, which has a direction, is called a subgraph, right? 23rd question. Explain in detail of searching. So searching is nothing but a process of finding a given value position in a list of values. It decides whether a search key is present in a particular data or not. It is nothing but an algorithm process of finding a particular item in a collection of data structure. It can be done on internal data structure or else external data structure. So we are going to see the searching techniques. To search an element in a given array, it can be done by two ways. One is sequential search, second one is binary search. Now we are going to see the sequential search. So sequential means line by line. We know it, no? Already. So this is also called as linear search, one after the other. Sequential search starts at the beginning of the list and checks every element of the list. Here it is a basic or a simple searching. This is also called as basic or a simple search algorithm. Sequential search compares the element with all the other element given in the list. If the element is matched, it returns the value index, else it returns -1. That is, the element is not found. The following figure shows the above figure shows you the sequential searching method. So first, according to this example, our element is like say for example 30, right? 30. So it goes from first element, that is 10. The searching element is not found, right? Then it goes to second element, that is 5. That will also not match. Then third one 15, that will also not match. 20, that also will not match it. 25. Then next comes to 35. So finally it says that 30 is not in your list. Likewise, if the element, say for example, second example, if you take a searching element as 25, it will go step by step in a sequential order. That is, it searches first element, that is 10, no. Then 5, no. 15, no. 20, no. Then 25, yes, it reaches my searching element. Then it says that my searching element is in the position A of 4, right? It will finally gives the address of the element, and also my searched element, where it is in the queue or not, right? Then next, 24th question, binary search explain. Binary search is used for searching an element in a sorted array. It is a fast searching algorithm with a runtime complexity of order of log of n. Why it is said means, because binary means 2. The total element is divided into 2, and it will search again the left node, say for example, if totally it has 10 element, it divided into 5. So first 1 to 5 and 6 to 10. Then again it divide 1 to 5 as getting as a midpoint 1 to 3 and 4 and 5. Then it searches. Then here 1 to 3 is also divided again. Then likewise, similarly, the elements are divided equally to part, and searching, we can able to search the element quickly and fastly. So according to this example, then algorithm program is given here. Say enter the size of the list, that is 5, enter integer value. So searching element is what the element is we needed, 20. So according to this, the element is searched and finally it gives the index of my searching element 20, right, which is placed in index of 2. Thank you.